Welcome back, Gangies. Late session, very late session today, but we were tied up with some work stuff. It really just do be like that sometimes. Fortunately, we cannot control the cards we are dealt, but fortunately, we can control how we play the cards we have. So, regardless of what has transpired, we got work to do. I'm actually not dreading the session today, but uh because I was doing stuff later, I didn't work out and eat yet, so gotta do that. And then gotta work on some other stuff. So, yeah, I was working on I was pretty much working on some work stuff. It do be like that sometimes, but yeah. So, what else can one really say? I think we have some comments, so we'll take a look at that, but I'm actually not certain. But let's just see, just in case. So let me set this up. Also, the beast was slain yesterday. How can one truly complain about that? So we're coming off a W here. I mean, actually, we have no comments, so that's okay. But yesterday we solved the problem that we are unable to solve. It seemed like all we needed was some Socratic guidance. And this is the power of some of these AI tools. It's pretty cool. I know there's a lot of talk about stuff like, is it just stochastic parroting? Is it just guessing the next character? I don't know. I feel like that stuff is kind of relevant. I feel like there are use cases now that are useful for it, and it kind of works. So I'm not saying it's the end all be all or that output is perfect or anything of that sort, but it's good enough. I've used it a few times, the conversational version, to learn about math. Not ask it to calculate equations, but just to understand. For example, I could understand how uh what sine and cosine represented in terms of coordinate plane and drawing circles. Now I kind of get it. I didn't have access to someone I could have asked a question to, but I was able to ask ChatGPT the question. It's kind of cool. The sad part is there's probably something you gain out of trying to find someone who can answer the question for you. Another chance to connect with another human being using your IRL avatar. But talking to ChatGPT, it's kind of like it removes many of the chances. I guess I would have, people would have gotten to potentially connect with another human being. So that's kind of a sad thing. Presumably, if I didn't have ChatGPT and we subtract 20 years from today, and the internet isn't that good, I probably would have asked a university professor or something. Maybe we get coffee or something. Maybe they tell me how this works. Maybe I ask a high school teacher. Maybe I already know someone. Either way, it would have been it would have sparked some kind of something, for us to meet in person or talk, or maybe just, I would say just spark a chance for connection. We missed that chance now, so that's kind of sad. And I imagine I'm using it for a couple of other projects too. And some questions I guess I could have asked, a game dev community or someone I know. I think that chance is also lost. So yeah, it's just, maybe we'll find new ways to circumvent stuff like this. But yeah, I guess, yeah, I guess, yeah. Maybe things have always kind of been like that. Maybe it's just worse now. I imagine in the early 2000s or something, before MapQuest and Google, if you wanted to go somewhere, you had to ask them in the area. Then you had to kind of connect with someone. Maybe you become friends, maybe you don't. Either way, kind of are sort of included in someone else's community. Maybe when MapQuest and Google and all that stuff came out, maybe people just didn't ask. Maybe it was fine. And it was just like, I can just Google and find the one that I want near me, which is also cool, but minus chances. It feels like I'm just rambling about some nonsense. It feels like we're kind of at the point where if you missed out on the chance to connect with peers either in high school, college, or work, kind of screwed. Work is already tough already to connect with. Plus, for better or for worse, so much content is being produced that every single niche is almost covered now. I imagine if two people, let's just say one person liked a joke in the style of A, another person liked a joke in the style of B, could be one medium that would have, both included. Maybe let's just say Harry Potter. But maybe with now that there's so much content, I guess in the past when there was just less content, two people might be able to, convene over the fact that they like Harry Potter, even if it's not for the same reasons. But I guess now the personal algorithm, there's so much of content A and so much of content B that they're their own categories now. Now these two groups of people that would have, I guess, otherwise considered themselves having a similar interest probably don't now. I don't know. Who knows? It's late. I'm loopy. I haven't eaten yet today. And we're just saying nonsense. This is besides the point. I'm just trying to say ChatGPT is both a blessing and a curse. And we'll see where things go from here. That being the case, if it's anything I love more than LeetCode, it's learning. And I gotta be honest, ChatGPT helps me learn. So I guess I'm dating ChatGPT. Maybe we're all dating ChatGPT. And this is the movie Her, 2017. Yeah, I don't know what I'm saying. That's besides the point. We solved the problem yesterday. I don't think we're gonna do more than 30 minutes a day going forward. Just more other stuff I'd like to do. Plus, I think 30 minutes a day is fine. We're not in a huge rush, and there are other skills to be gained. That being said, though, solving yesterday's problem was very, very satisfying, and with the Socratic guidance of ChatGPT Model 4, kind of flames. So if we get stuck again, I don't think ChatGPT has to know the answer, but if it can guide us in the correct direction without using any code, that'll be awesome. So I'm going to switch to the LC scene. And yeah, I think today what we're really just going to do is just keep it a buck dowie. We finna just read the solution. The version we implemented eventually was pretty much we have to find the next permutation given an array of numbers. And the next permutation is the one that is lexically greater, right? But lexically, something being lexically greater just basically means that if you were to scan both arrays from left to right, as soon as you find two elements that are differing, right? The element that, if you consider both differing elements, the element with the larger element, literally like an integer version, is the greater array. That being the case, since that's possible, what it means is that lexically greatest version of an array means that the array is sorted in descending order. And the start would be that the array is sorted in ascending order. So what we can do is start from the end of the array and basically just check some simple things, right? We have 1, 2, 3, for example, here. If we take 3, we start at 3, right? There's no other choice we can make, right? We can't swap 3 out for anything because there's nothing after 3. We go to the next index, which is 2, right? Now that we're at 2, right, we see that there's nothing that we can swap 3 with, right? Because we need at least 2 options, right? So we go back to 1, right? And we see that 1 is, what did we do? 1 is greater than, yeah. What was our approach? For each number, we assess whether or not a greater lexical permutation is possible. If so, we create it. We know a greater lexical permutation is possible if a larger number exists after the current number. True. Yeah, so if it's said in descending order, there's no greater lexical permutation possible. So if we take a number and the numbers after it has a number bigger than it, we know that a greater lexical permutation is possible, right? So when we start at 3, there's no other option. We go to 2, we have an option here that's 3. We know that 2, we look at 2, right? We know that the next number is 3. So the next largest index is 3, which means there is a greater lexical permutation possible here. Since there is, at line 68, right, we found one, we'll swap 2 and 3. So we swapped 2 and 3. Now we have 1, 3, 2, right? Then to get the next permutation, we have to take the smallest possible number every single time, right? It just so happens to be that our array is very small here. So once we do 3 and 2, we start our array at I plus 1, which is index 2, right? And there simply is no next smallest index. So we end up swapping 2 with itself when we return 1, 3, 2. In the case of 1, 1, 5, when we get to 1, we realize that a greater lexical permutation is possible, right? Because 1 is less than 5. Since that's the case, because 5 is greater than 1. Since that's the case, right, we try to find the next greatest number, next smallest number greater than our current number. That would be 5, so we place 5 here, right? Then we do our last, our array option here, right? We do I plus 1. 1 is already where 5 used to be, so we're done. Let's just say if we had one more index, right? Let's just say 2 was included. We would have placed 2 after the 1 with this for loop here. Overall, I'm struggling to figure out what our approach is. We're pretty much just building the next permutation from the current permutation. I don't know what approach you would call that. An editorial. Oh, right. We did the brute force version. We find out every possible permutation of lists formed by elements of the given array and find out the permutation which is just larger than the given one. This one would give a very naive approach since it requires us to find out every possible permutation, which will take a really long time, and the implementation is complex. Thus, this approach is not acceptable at all. Hence, we move on directly to the correct approach. Right, we considered this before. It would be n factorial because of all the possible permutations. At max, given our constraints, we were going to get at least 100 numbers. It's impossible. Typically, with exhaustive searches of permutations, your max is like 12 or 11. A single pass is different. In fact, I think our version is n squared. So first we observe that for any given sequence that is in descending order, no next larger permutation is possible. That is true. For example, no next permutation is possible for the following array. There's no way to arrange the numbers we currently have, right, such that the array would be lexically greater than the current array. We need to find the pair of two successive numbers a sub I and a sub I minus 1 from the right, which satisfy a sub I is greater than a sub I minus 1. Now, no rearrangements to the right of a sub I minus 1 can create a larger permutation since that subarray consists of numbers in descending order. Thus, we need to rearrange the numbers to the right of a sub I minus 1, including itself. And what kind of rearrangement will produce the next larger number? We want to create the permutation just larger than the current one. Therefore, we need to replace the number a sub I minus 1 with the number which is just larger than itself. among the numbers lying to its right section, say a sub j. That is true. That's why we made the next smallest number idx function. We swap the numbers a sub I minus 1 and a sub j. We now have the correct number at index I minus 1, but still the current permutation isn't the permutation that we're looking for. We need the smallest permutation that can be performed by using the numbers only to the right of a sub I minus 1. That's true. Once you place this one here, right, to get the earliest lexical array, you have to arrange the numbers from smallest to largest, or in ascending order. But recall that while scanning the numbers from the right, simply kept decrementing the index. Find the first decreasing element, found it, find the number just larger than 4, which is 5, swap them, and then you get all the numbers to ascending order. Oh, since they're already in descending order, to get the lexically earliest version of it, they just reverse it because it'll be in ascending order now. Does that work every single time? There's no way. While I is greater than 0, num sub I plus 1 is, so while I is greater than, so they start 2 minus down like we did because there's no options. So while I is greater than 0 and num sub I plus 1 less than num sub I, less than or equal to num sub I. So num sub I is less. So num sub I is greater than I is plus 1. Once we find it, if I is greater than or equal to 0, if I is greater than or equal to 0, int j is equal to nums.length. I is greater than or equal to 0. J is equal to nums.length minus 1. I is greater than, so let's just take a sample input they give us. Nums.length minus 2. 1 gives you this element, 2 gives you here. Num sub I plus 1. Num sub I plus 1 is less than, oh, okay, less than or equal to num sub I. Right. Let me go to this one. Right. Num sub I is less than num sub I plus 1. This one. Num sub I is less than num sub I plus 1. Go to this one. Num sub I is not, is num sub I is greater than or equal to num sub I plus 1. Not. So I actually equals 0, 1, 2, 4. So while num sub j, right, num sub j is less than or equal num sub I 7. Oh, right. So he's 0, 1, 2, 3. Right. I'm going to say num sub j is 4. No. Is 1 less than or equal to 4? Yes. Is 3 less than or equal to 4? Yes. 5 less than or equal to 4? No. We swap 4 and 5. Then we reverse the remaining array. That's the interesting. Yeah, I'm not gonna lie, that's a little bit nutty. That is a little bit nutty. I guess it's an okay problem, but that was not the solution. Yeah, I don't know. That was okay. It was fun to solve it though. Even though it took a while. So here we have search in a rotated sorted array, whatever that means. There is an integer array nums. Integer array nums. If an array of numbers sorted in ascending order with distinct values. That's useful. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index, k. Right? K is at least equal to 1, but less than nums.length, such that the resulting array is nums sub k 1. Right. So if, yeah. So rotated just means that the index now becomes the first index, wherever it was now becomes the first. and every element after simply exists after that index. When we reach the end of the array, we loop back up to front. Given the array nums after the possible rotation and an integer target, turn the index of target. Given the array nums after the possible rotation target, return the index of target if it is in nums, or -1 if it is not in nums. Must write an algorithm with log of n runtime complexity. Oh, the obvious solution is just linear search for target, but that's not okay because they want log of n. So now I'm immediately thinking binary search, but we have a bit of a strange problem. Since our array is rotated. So sorting isn't possible because that would take n log n. Can we augment a binary search to work with a circular array? Binary search typically works with non-circular. I can't see this problem as anything other than augment binary search. Can't do any linear time checks to find where the boundary would exist, so there must be some natural way to augment the binary search. Let's just run it as is. If we were to search for a target 0 in this array as is, right? We typically calculate the pivot as the midway point. We have 4, 5, 6, 0, 1, 2, and then we'd have 7. Right, midpoint would be 7. Is our number less than or greater than 7? Our number wait, can we just flip them? 0 is less than 7, but if we go left, we end up messing up, right? So let's just say now go right instead. Now we're closer to finding it. Our range is now 0, 1, 2, 3, 4 to 6. So we would do how do you calculate the pivot again? Is equal to math. This is like math, not floor right minus left plus left. Right minus left. 6 minus 4 is give a 2. Over 2 would be 1. Left is actually 0, 1, 2, 4. So yeah, the midpoint would be 1. Right? Is 0 less than or greater than 1? Less than. Now we definitely want to go left. So why didn't we want to go right before? Mm. We know that the array is sorted. It has to be sorted in ascending order. No, I'm thinking we could do it actually instead of comparing the target with the pivot to a distance from the target. That wouldn't make sense. I don't think that's the dimension we're actually trying to check for. Technically, 6 is closer to 0. Actually, no. could also do search both halves at the same time. Wait a second. We could also search to find. We could also search to find the split, and if we do that, this order is broken. To do that, we can search both halves at the split and return if we find it. I think that could work, but we're a little strapped for time, and I think we'll stop there for today.